Hey guys, so it's been a while since my last video, since I've had to put a hold on my brand new 3D printer build. However, thankfully I've got something that's actually worth showing you, and that is the new TMC 2209s, and in this case I've got them on the SKR mini board from BigQ or Big 3 Tech. So as you can see on here, let me just swap that over. These are indeed the TMC 2209s from Trinamic. Brand new drivers. They are the successor to the very popular TMC 2208s. So they use UART communication. So you get all the nice stuff like the ability to change the current from the software. You get the stealth chop, which is obviously one of the big reasons to get these because they're very quiet. However, they do handle more current than the TMC 2208s, which is great, and they have sensorless homing, so you can enable that on here with just a few jumpers going from the connectors here, so you can change those over. Now, one big thing with this is obviously this is the version that has the driver just soldered on, and that is meant to actually give you better thermals for them because they're allowed to dissipate heat into the board. Now, similarly, the MOSFETs for the bed and the hot end have the same kind of thermal vias, so they should also dissipate heat into the board, and you can see that they don't have any heat sinks on them. There's no heat sinks for the MOSFETs, but to be honest with you, I had a quick look through the spec sheet and they seem to be able to handle way more current than I'm going to put through them anyway. Plus, to be honest, I have a separate MOSFET for the heat bed on my printer anyway, so that's fine. Okay, now this is, as you'll be able to see on here, so this is the SKR Mini E3. Now that means that it's a board that's specifically made for the Ender 3. However, if you recall from the last video, I've got an Anet A8. Now this was about £23 when I bought it, and I pretty much ordered this as soon as they became available. So June 20th I ordered it, and it's taken over a month for me to get it, just because brand new board, brand new drivers, it's taking them quite a while to actually build these things and fulfill the orders. But that does also mean that some of the software is a bit hit or miss. So we'll have a look at the software in just a second and the issues that I had setting this up. Okay, now one thing I was a bit disappointed with is, to be honest, when the board comes, you get the board and it has a small micro SD card. Now, with this being a 32-bit control board, the firmware updates are actually done via the SD card. Okay, so this had some firmware loaded onto it, but of course I wanted to change some of the parameters, and actually I had to change quite a lot to get it working with the Anet stuff, but I'll show you that in a bit. The main thing I was quite disappointed with was, well, I figured no big deal, I'll just go into the GitHub for the page. So this is here, and you know, they have a version of Marlin already configured, pretty much ready to go, supposedly. So I downloaded that, I tried to build it in Platform.io, which is the preferred way of building Marlin 2.0, and it kept giving me errors. So, you know, I was quite shocked by that, finding that downloading their version just gave me errors. And I couldn't figure out what was wrong, and in the end I actually realized that if I went over to, let's see, so if I went over to the Big 3 Tech GitHub, they actually make a slightly different version of the same board with socketed drivers that is called the SKR E3 DIP. And what I noticed in here we go, this had a mention, and this was that the TMC stepper library, the actual version that you normally use, doesn't work with the TMC 2209s yet. So what you need to do is actually load up Big 3 Tech's own version of that. And if you do that, so you do that by changing the platform.io.ini. So if you change that file here, and this is the libraries that it uses, then you can actually get this to compile without an issue and build. Now, obviously, once you've done that, you can just follow the standard instructions that they give out on here to make the changes, get this all set up. And to be perfectly honest, if you've got a Ender 3, then that's perfectly fine. That is going to be you up and running, and then you can just play with a few settings. Now, to be perfectly honest, there is some things on here that I didn't find it to be completely right. So for example, on here, they're saying to comment out the EEPROM settings. Now, I find that setting really useful. I might be wrong, it might be breaking stuff, but I've actually enabled the EEPROM settings on here. Again, on the 32-bit boards, what they do is, because they don't actually have an EEPROM chip, they write a file to the SD card with all the settings, and then they can load that over when needed. And that seems to be working fine, at least as far as I can see. But yeah, once you do that, to be honest, you're pretty much ready to go if you're using an Ender 3. Obviously, because I am cheap and stubborn, I wanted to use this on my Anet A8 and I didn't want to buy anything else. So that gave me a few issues, but what I'll do is, if you're using an Ender 3 and you just want to see the board working, then I'm going to put a timestamp so you can just jump straight to that. If you're trying to use this on an Anet A8 or anything similar, then what I'll do is I'll show you a few things that I've had to do to change it to make it work. One of the big things, to be honest, is just connectors. So the Anet A8 actually uses 3-pin JST connectors for a lot of the end stops, as well as the thermistors. So there we go. Nice standard 3-pin JST connector. Now this is just a blank one without the pins, but usually what you'd want to do is simple enough. You push the pins in, click them out, and then you would change them over to 2-pin connectors, and then they just plug right in. So that's nice. You don't have to actually do any crimping. You just have to change the pins over. There's a few other things. So similarly, obviously the board here, now that, if you notice, only has one socket for the Z motor, and that's because the Ender 3 only has one motor for the Z axis. Now the Anet A8 has 2 motors. That's solved easy enough with a splitter. Now you can buy the splitter, but again, I wanted to get it done as quickly as possible, so I just made one. Nice and easy, just same signal to both servos, and you know, that just plugs into here and I can plug in my 2 motors. So that's easy enough. And then obviously I'm gonna have to change some of the firmware just to account for the A8's frame and motors. By far the biggest and the hardest thing to actually get working was the screen. So again, I was really stubborn, because you could buy a CR10 or an Ender 3 screen for about 12-13 pounds. But you know, I figured that was way too much to spend. So what I actually did was, without any support from Big Tree Tech or Marlin or anyone else, I actually managed to get it working. Now, probably one of the biggest things to look at is the pinout. So while the cable itself is very similar, so obviously same kind of cable that a lot of the screens use, and it's just the one connector that you would use on the SKR mini board. However, the pinout is completely different. So what I've had to do first and foremost is actually rewire the connector. So let me show you. Now, you can do this a whole bunch of ways. This is just the way that I thought was easy. And here we go. So this is the way that the connector is on the actual SKR mini board, and this is also obviously the normal pinout for the Ender 3 LCD. Now this is the way that the cable for the Anet A8 is usually wired, so you can see there's a lot of differences here. Now I've highlighted the ADC keypad pin because that's going to be quite important, and that actually I spent a few days to try and get it working. Okay, so the way I chose to do this is, the easiest thing I could think of was to just rotate the whole thing. So actually on the Anet LCD, you can take the little plastic shroud. So I chose to do on the LCD. You could also do on here, but basically this plastic surrounding, you can actually pry that up with something flat and flip it over, you know, just rotate it. And that gives me this layout for the pins. Now this is a little bit better. You can see we've got power on the bottom, although they are reversed. Now we have these pins, the data pins for the LCD, which just line up with normal pins. We have not connected, which is fine. We have the RS, that again is just a pin we can redo. Now this was an issue. We've got the reset pin, which isn't used on the Anet LCD, and that is right where we need to have an enable pin. And then the top one, again, the keypad pin. Now that actually needs to plug into one of the pins that can have an analog input on the board. Now I had a quick look through the STM32 because this is a STM32 based board, and basically the only analog pin that I could find that was available was actually PA1. So PA1 on here is that pin on the servo connector. Now that obviously if you were using the BL Touch or one of the clones, the ones that need a servo, then you would want to find some, well, you'd probably just want to get another LCD. But since I'm not wanting to spend any more money on my Anet and I'm not gonna use the BL Touch on there, I had no issue in repurposing that pin. So going around, then again, these pins, they're fine. We need to swap over the 5 volts and the ground pins, and that's easy enough. That's just left alone. And then again, that one's just left alone. The EN moved over to PB6 on the connection, and then what I had to do is basically break out the ADC pin for the keypad out of the ribbon cable and put it on a separate connector to go onto the servo. So what I ended up with is basically this. So, and then this is the connector that goes into the servo port on the board. Okay, now the way I did this is basically pry these up and the whole connector comes apart, and then you can rearrange the wires and sort of click it back down. I actually broke the little plastic parts on it, so I had to glue it together, otherwise I would show you exactly what I did. But you can kind of get the gist of it, and then again I soldered on a new little bit of wire to go into this connector, and that way this just plugs in like that. Now, one big word of warning, and I'm very serious here, don't do anything else before you think about this. On the Anet and a lot of the other 8-bit boards, your pins are mostly 5 volts logic, and actually even your ADC is 5 volt logic. On a lot of the 32-bit boards, this included, it works on 3.3 volts. So if you just wire that up as it is, you are gonna fry your board, so don't do that. Okay, so what I had to do actually on the Anet LCD is, and I'll show you on here, I've got a photo of what I did. Okay, let's see. So basically, here we go. So this is the 5 volt supply. Now this goes into these voltage dividers, and this is basically how the board actually detects button presses. So what I did is you cut over here, you cut the trace so that there's no 5 volts going through, and you get a 3.3 volt regulator. Now I only had these on hand, which is way overkill switching power supply 3.3 volt regulator. To be perfectly honest, you could buy just a linear 3.3 volts regulator, something like that. It would do perfectly fine. You know, dropping 5 volts to 3.3 volts is nothing. And that would be much easier and probably a little bit neater than what I did. But this did work. And again, you can see on here that I had to swap the plastic bit around on the LCD connector on here. But yeah, so basically I cut the trace there, so it's that top one here. Let me just zoom in a bit. So that top track there, I cut that somewhere underneath here. And then what I did is, this is the input, so that's soldered on, bringing 5 volts in. Now this is a big ground plane, so again soldered that on. So I've got 5 volts and ground going into my voltage regulator, and then I have 3.3 volts going out into the voltage divider for the keypad. So that was all the hardware connections and changes that I had to do to the LCD. However, even after this, I didn't actually get it working, and that was due to some code. So of course, to go with the change in pinout, I had to change the pins file in Marlin. I expected to have to do that, so here we go. Changed up the code a bit. So I've still left the CR10 display options on here, changed a few of the things around so that it doesn't interfere with my Anet LCD, which is also known as the Zone Star LCD. So again, these are pretty much just standard pinout. You can tell that just from here. And then again, PA1, which is one of the ADC channels, is the only pin that I could find that was an ADC channel that wasn't in use, you know, because all the other ones are used for stuff like actual temperature measurement, for example. So I did that. However, I did that and it didn't work. And main reason for that, and this took me, again, it took me about 2 days of looking at code and actually reading forums and stuff. And to be honest, now I feel kind of stupid about it, but thankfully I did get it to work. And that is, if you actually go into the HAL.cpp, which is part of the hardware abstraction layer, so that is what makes it possible to run Marlin on all these different boards. For whatever reason, when working with the STM32, they chose just not to initialize. So this I had to add to initialize a ADC channel for the keypad pin. So I just added that on in a few places actually. Here we go, ADC keypad and ADC keypad. So once I added that, actually, that initializes the ADC for that channel, so you can read it without an issue. I'm not sure why they decided not to do that in the first place. I don't know if it was just an oversight or if it actually messes something up. So don't take my word for it. If you know of a reason not to do this, then by all means buy a better screen. But it seems to be working okay for me, and I'm very happy that I was actually able to figure that out in the end, although it did take me a lot longer than I was hoping. So yeah, I changed that and then it was pretty much all good. Obviously, changing that, you also do have to change the actual controller type in the configuration.h file, and here we go. So obviously disabled the Creality LCD and enable Zone Star. But yeah, that was the first thing, is when I first tried to do that, then obviously the pins file, it has this, which means if you try and use anything apart from the CR10 stock display or the Ender 3 stock display, it just tells you nope. Which I get why they want that, because obviously you don't want a lot of people frying their boards by trying to use stuff like the Anet display. But it is possible, so that's quite nice. Obviously you can't use any of the like full graphic controllers like the RepRap stuff, because they use 2 cables and the board actually only has 1 header for the LCD. But yeah, as far as I can tell, I'm the first one to get that actually working, and so far as far as I can tell, it is working, so that is great. Now again, obviously I made a few other changes to the board. I did put in my own PID values from my current Marlin configuration, even though that is obviously 8-bit Marlin. But I just copied those over, although I'll do some more tuning now that I have the printer more or less working. And then there's just a few settings, like setting up the different type of driver, which obviously just they're actually on the SKR wiki just here, and they're quite good settings as far as that goes. So apart from the few things that stopped it from working, the GitHub isn't half bad as far as a resource to get it working. And yeah, so once you change everything and the configuration.h and configuration.advanced files, and you have everything working, Control-Alt-B is the shortcut to build in Platform IO. Okay, so once you've got that built, now what I usually do is I can just click Reveal in Explorer, and then if you go into your PIO envs for environments and then Bigtree SKR Mini, you're gonna find that you've got a firmware.bin, and what you can do is just copy that to your SD card, and then when you power that on with the SD card in, it's gonna start flashing it. That should pretty much be all the setup to get you up and running. If you're using the Ender 3, then you have a much easier job, but it is very much possible to use it with the Anet A8, which is what I'm doing. And honestly, for the 20 odd pounds that I paid for it, it's a hell of an upgrade. That's, to be honest, one of the main reasons that I went for that, because I don't really plan on doing any other big updates to it. Since I would much rather spend any free money and any free time into designing and building my own printer. But that's gonna have to wait for a little bit. Okay, so what I'll do is I'll show you the actual swap over on the Anet, and then we can compare the before and after. Okay, one thing I almost forgot actually, before we go over and install the SKR board on the Anet, is I'm still using the Anet stock acrylic frame, so I had to make an adapter to actually be able to screw the board onto the frame. Now what I did is, because we have some schematics from Big Tree Tech, so this is just on the GitHub, so it gives you dimensions for most of the screw holes. Now there is some guesswork to this, to be honest. So you know, how far in is that screw hole? It doesn't say really. I assumed everything was 2.54, although it's approximately correct. But yeah, that was all a bit of guesswork. But with that, I loaded up SolidWorks, and what I ended up with is basically this. So that's just a nice little adapter, 3D printed, and it screws onto the frame, and then the SKR board does screw onto it. The screw holes line up fairly well, and I gave it some standoffs, so I did that for a few reasons. Now I did that so that the board could have some air running around it just for cooling, but I also did it because on my printer, the way I've got cables managed, I actually have a few cables running underneath the motherboard at the moment with the default standoffs, and I want to keep doing that. Perfect. What I'll do is I'll actually put this on Thingiverse, so if anyone else needs it, they can download the files, and I might put the CAD files on there as well, so you can modify them if needed. Actually, I've been quite lucky with this, and the fact that the layout for the board isn't that different. So we've got SD card and USB at the top. We've got LCD connector near the top on here. Now we've got all the sensor connections on here. We've got power and heaters in that part of it, and then we have our servo motors on the left. So it's a little bit different from the Anet, but it's close enough that we can just about get that working. So keep in mind, you do need quite long screws for this. You might even want to reuse the original screws. With stuff like this, I always recommend putting in all the screws loosely, just so you make sure the holes actually line up, and then you can tighten them as you go until the whole thing's secure. Now, my design for this adapter does actually have you just thread the screws into plastic, and I know this isn't ideal, but it works well enough, and I didn't have any threaded inserts. Ground on the outside and power on the inside, but yeah, this should really be something that they put on here, just, you know, as a sill screen or something, and I hope they do in later revisions, because this is quite confusing, and obviously if you get it wrong, there is a chance of breaking something, but I'm pretty sure I've got it the right way around. That should be more or less all the connections from there for thermistors and stuff. So that leaves us with the two connections for the Z-axis motors. So again, just plug both of those into the splitter like so, and then just plug them into the port labeled ZM. Then the last thing I need is just to actually plug in the cable for my LCD. So again, this is the cable that I modified, and let's see, one end goes right into the LCD on here, and then the other end has that connection there, so one bit of it goes on to the actual LCD header and one bit goes into the servo port so that I can access here we go, so that I can access the ADC. Okay guys, so I've had the SKR board for a few days now. I've had it installed in my printer, so it's probably a good time to make a conclusion regarding the video and regarding the board itself. Now, what I wanted to do is I wanted to have a before and after for this upgrade, just to see what kind of difference it makes. And to keep it consistent, I wanted to print, a reference file, so I thought calibration cube. Now, if you can see on here, one big issue was when I wanted to start this, Thingiverse was actually down, so rather than being able to grab a fresh new calibration cube and slice it, I had to rely on an old G-code file that I found on one of the SD cards I have. And I don't know if you can see that very well on here, but yeah, that file had some major issues, so that was a pretty bad idea, and both of the cubes ended up looking pretty rough. However, they are still good enough for the sake of comparison. So one thing we can definitely see on here, and the cube on the right, which is the one that was printed with the newer board, the SKR with the trinamic drivers, that does have quite a bit less ringing and ghosting, especially around features like the lettering. And that is usually due to smoother motion. So obviously that's one big upgrade with the SKR drivers. And the other big upgrade is obviously due to that smoother motion, they're also a lot quieter. And that's something else, printing with the exact same G-code and the exact same settings, because I did copy over my settings from the old firmware onto the new firmware for things like acceleration and motion speed. So we can see just how much quieter the printer is. Now, one thing obviously is on my A8, the smooth rods for the bed motion, they're very not smooth, and I'm pretty sure very not straight. So that is still fairly noisy. But it's much quieter with the SKR board with the trinamic drivers than the Anet board, and to be honest, that alone for me makes it quite a worthwhile upgrade. The other quite good thing is, unlike the Anet board, where to be honest, even just to have Marlin with a few features like manual bed leveling enabled, that pretty much took up all the program space, so I was really limited. I actually had to give up on some of the features and some of the G-code commands that you can use for troubleshooting and stuff like Pronterface, and that really annoyed me. With the new board, actually, not only do you have enough program memory to have all the features enabled that you'd want really, but because it's a more upgradable board, you do also have extra connections. So obviously on the board as I'm using it now, I'm taking up the Servo connector to make the keypad work. However, there's other connectors, there's stuff for SPI, there's connectors for serial data, so you can plug in things like the TFT screens, or you can use a variety of little cheap Wi-Fi modules with the ESP32s. You can use bed leveling probes of all sorts of different kinds, and other stuff like RGB strips. So that's the other big upgrade, is going from the stock board, and this applies even if you're on a different printer. So say if you're on the Ender 3, which is actually the target printer for the SKR Mini, it does mean that you can upgrade a lot more things in the future. It opens a whole lot of opportunities. But this is the video for now. Let me know if you've liked this video. I am thinking of making more videos in the future and try to upload a bit more often. So if you want to see that, then do also subscribe. I'm going to try and make these videos interesting, and definitely let me know if there's anything you'd like to see. But that's it for now. Thanks for watching.